Good evening and Assalamualaikum. Okay, we will start our topic today. Today we'll cover the last two topics, which is the topic, it's topic 8, 9 and topic 10. But in the book, it is in the textbook, yeah, by Sharda textbook, yeah. It is at chapter 7 and chapter 8. Yeah, they are at chapter 7 and chapter 8 in the textbook. But in our notes is topic 9 and topic 10. So we'll cover these two topics today. Next week will be your presentation, and then at the end of the next week we'll just do a recap. I think by time today you all know that you will receive your what date will you be receiving your question, receiving your assessment for your ODL final assessment. This is for final assessment. Okay, this is another one for ODL. So you'll be receiving your question, examination question on the 20th of August. 20th of August. So you have 36 hours. 36 hours. Okay.
Prof, is the 20th of August the submission date or?
I'm not sure date, yeah. What is it? This is the date. I think this is the
submission date, I think.
Submission. That is submission deadline.
Yeah.
Submission
so it's 36
deadline.
hours before that, lah.
36 hours.
So 5 AM on 19th.
Why 36 hours? It's supposed to be
3 days.
3 days.
Okay. 72 hours, Prof.
72 hours. Did you receive your timetable?
Yes, Prof.
Yes.
It's 36 hours.
36 hours. Can you email to them? No, I will email to them. Not one.
Thanks, Prof.
Not 1.5 day.
Thank you, Prof.
I just realized it. I just received. I think we received it the same day. I received it. When did I receive this? I received this on the 11 hours ago. Today, I received it today. This morning.
Same, Prof.
Yeah, same. So 36 hours. It's supposed to be 72 hours. 3 days. Actually, you can answer it by 2 days. The exams, the questions are not that difficult, but they have to do some tasks, so it will take about 48 hours to do. But I will text Sadrina to adjust it to 72 hours. Okay, today we'll cover the balance two topics, which is wait, I'll get to share my screen. I've uploaded the notes to you. Pending is actually the I lecture. Okay, and let's see topic 9. Topic 9 will cover. We will cover big data. Yeah, big data. So I think because in the beginning of this course, I've mentioned about big data. So I think by now you know that big data is not just big data. It's not just about huge data. It is about there is a proper definition or stipulated definition for big data. Okay, traditionally, big data just means massive volume of data. So this data can come from everywhere, from your weblogs. Weblogs is the actually blocks, weblogs. And then RFID, radio frequency identification. They have sensors. You have GPS system, your sensor network, actuators, your social network, internet-based text document, internet search index, detailed call recording, and then many more. So, but we are aware that from works, I think research done by McKinsey, I think sometime in 2012, around that time. And then there are also other researchers that mentioning that the data in the internet, mostly about 80% to 85% are unstructured data. So the difficulty in handling big data is the unstructured data. Although there are people saying that they are doing big data, but they confine themselves to structured data. So those are not big data. It can be termed as lexically as big data, lexically, but stipulated definition of big data is much more than that. So we know data getting bigger and bigger. Facebook, now Meta, have larger data. This is and then the technology, okay, this is what do you mean by data, yeah? Gigabyte, prontobyte, and so on. This is just standard SI, yes, the System International Definition for sizes. And then big data, like I mentioned to you, is a misnomer. It is not more. It is not just big. It is. There are 6 V's for this big data. First, with volume. You know that big data comprise of volumes of data. So we have large volume of data coming to you. So you need to handle big data. And then besides that, we have variety of data. Okay, we're talking about variety of data. Not all data are structured. Even structured data, we have integer, we have character, we have string. Yeah, so data can come in many formats. Even the structured, we have structured. And then we have unstructured. Okay, even the structured data, we have some data which is captured by human made data, and then there are not human data. I mean that is captured by machine, machine, not captured by machine. So things that and then so does the unstructured data. There are human made, and then there are machine captured data. Okay, and then even though we have this human made and captured data, and then confining to human made data, we have formats like even both of these. You can say both of these. We can have data that come in the format of we have integer. We have integer. We are in string, in text, or in certain character. Many format of data, real number, and so on. So so we have covered this in the beginning of this I think chapter topic 2, I think topic 2 or topic 3, this topic data, and then machine captured data. Machine captured data, same thing. And then this comprises of about, say, between 80 to 85%. This is left with 15 to 20%. And then unstructured data, the 80 to 85%. So by then you know that the most difficult part in handling is unstructured data. Structured data can include, besides the integer, string, character, which is not in structured format, you can include images, sounds, audio, video, etc., and many other formats of data. So that is variety. So that is variety. We have data, and then we have velocity. The data coming very fast. We have terms like batch processing. We have terms like data are done in OLAP, in batch processing. Oh no, we have OLTP, online transaction processing, and we have batch data that are being process. Yeah. So on this part, this variety, we have done variety, and then velocity, data can come in batch, and then data can come in streaming data. Streaming data, we call it OLTP, online transaction processing. Yeah, OLTP, online transaction processing. Data will be processed online, and will be processed by batches. And then we have veracity and variability. This come from IBM. Yeah, veracity, data need to be proven, need to be accurate. Yeah, there's certain quality of data, and data can be into a variable. Yeah, can be into a variable of data. Yeah, we talk about variable. Yeah, we talk, and then that this is from IBM. Veracity data can be, because the other part, the volume, variety, and velocity was initiated by was coined by Gartner. Yeah. And then the veracity and variability come from IBM. Yeah. So veracity is about the verifiable. Is a term they coin, verifiability of the data, meaning that data can be verifiable. Data is accuracy. You have provenance for this data, so you can, yes, so that is veracity. And then variability, the data can be made into variables, and you can see variables of this data. And then there is another term come in, I'm not sure from where, means data must have value. And there is contribution of the data to create value in for human, for businesses, for community, and so on. There is value for this data. So big data is not just about large amount of data. It comprise of this definition. We call it stipulated definitions of this big data. I think we have covered that. So high level conceptual architecture for big data solution is by Extra Data. They look into a unified architecture where they can have sources of this data coming from various sources, big data sources. Show you big data sources here. Okay, big data sources, which include ERP, SEM, CRM, images, audio and video, machine graph, text, web and social. So all this kind of data, all these diverse types of data, it can be in different format. Yeah, with volume, with velocity, with variety. It come into the data platform. So the elephant is actually a logo for Hadoop. The elephant is a logo for Hadoop. Hadoop logo is elephant. So it will integrate this data with the data warehouse. So the possibility of because data warehouse is a structured data, so we integrate it with that data warehouse, so we can have a discovery platform. So this is by Extra Data. So we process web data. We can have event processing straight away to the discovery platform, or from Hadoop it goes into event processing, or you can from Hadoop straight away go to the combine with the integrated data warehouse. Integrated data warehouse. Data warehouse is a structured data. Yeah, remember we talk about data warehouse. Data warehouse are structured data. It's not. It's different from big data. And then we will combine. You can apply them in various areas in your organization, in marketing department, in several other applications, in business intelligence. You can use in data mining, because once you have this data, it is structured in your data warehouse. You can use it into your data mining. You can use it for mathematics and statistics, in languages, computational linguistics, and so on. And then it can be used by the the staff involved, marketing executive, operational system, customers, partners, frontline workers, and so on. And so these are users. These are the analytical tools, and these are users. This is a high level, and just a sample. Because actually in reality it will depends on the solution that you apply for this big data. So okay, big data by itself is actually is regardless. Yeah, big data It's just a big data. So there are two terms here. We have big data. Okay. And then there is another term called big data analytics. Yeah, so big data by itself, it doesn't serve any purpose, because when I think your batch does not learn MIS. We have this topic we covered in MIS. We have data, we have information, we have knowledge, and we have wisdom. This is called the tiers, the IKW tiers, the IKW tiers, and the IKW. So from data, it become, because it's not covered in your batch. I think you don't have MIS. So from data, you became information. From information, it became knowledge. From knowledge, it became wisdom. Okay, we exclude wisdom for the time being, but you concentrate on these three: data, information, and knowledge. Okay, I just want to inform you what is big data. You need to know what is data first. Okay, how can you define data? I think we have covered that earlier. Anybody can define data? Jefferson.
Facts and statistics. Data, facts and statistics.
Okay. Yep. Okay. The first one is right. The second one is a little bit way off.
Okay.
Facts and it can facts and science. They are just facts and science.
Oh yeah, facts and science. Yeah.
Facts and science. It's not statistics. Statistics become information. Yeah, facts and science. Facts and science, which are meaningless. It doesn't convey any meaning, doesn't represent any meaning. So these are facts and science which are meaningless. You have 35 kilograms. So what is 35 kilograms? So 80 kilograms. Height, 5 kilometers. Oh, distance, 5 kilometers, 5 meter height. So what is it? So it doesn't provide any meaning. So that is, this is data. When you combine or you integrate data with another data, you combine data with another data, it becomes information. So it becomes information. Data become information. And then when you information, you have information combined with data, combined with other information, combined with your understanding, it becomes knowledge. Yeah, understanding and experience plus information plus data, then only become knowledge. So knowledge is the highest most that we can understand today, that computer can apply today. In artificial intelligence and so on, we apply knowledge. And then we have information, we have MIS, ERP, CRM, so on information. And then data is the lowest level, which is just facts and science, which are meaningless. So when you say data, big data, whether it is small data, big data, combined with volume, combined with the velocity, combined with variety, and so on, they are meaningless. Yes, so big data are meaningless because it's just data. Maybe it is a integer, so it is a string, or it is a character, or it is an image, or it is a video, or it is anything. So they are just data, facts, signs, symbols. They are meaningless. So big data is meaningless. It doesn't provide any value because it doesn't have any meaning. So in order for big data to provide value, you need to have some form of processing. So it is called big data analytics. Big data analytics is this there is two definitions, BD, abbreviation BD and BDA. Yeah, so you need to be careful because I saw some people say, okay, we have big data, and so on, but what they refer to is big data analytics. Big data analytics is different. Big data is big data. Big data are the data. Big data analytics is the analysis of the big data. So big data plus the big analytics, then only we get the value. So to have a value a proposition for big data, you need to capture. You need to be able to capture, store, and analyze the big data. So you need to have some kind of new technology so that you can capture this data, because this data come in various format, and then this data are very fast. We have velocity for this data. This data in have volume, so you need to have some form of technology to capture this data. And then where do we keep this data? And then we want to analyze this data. We can have what do you call it? Memory-based computing, meaning that at memory level, at the RAM level, we process this data, we analyze this data at RAM level. So that is memory-based computing. So analysis, processing, memory-based processing. So this is, we need to find to have a proper value proposition. We need to be able to effectively and efficiently capture, store, and analyze big data. So we need to have a new kind of technology to process this data, because we are looking at analyzing big data. Big data have their characteristic. Remember, big data have their characteristic. So compared to the normal structured data, so big data have their characteristic. Most of them are unstructured and they are very large and so on. So we have these 6 V's or 5 V's of big data. So they have these 3 V's or 6 V's here. Yeah, so, and then so big data analytics must be able to cater these 6 V's. So that is big data analytics. Okay, I hope everybody can follow. If any question, just ask me. So you can, the big data challenges, the challenges or consideration you need to look into when you deal with big data. You cannot process, there are some, because sometimes there are limitations on your current platform, and then you cannot process the amount of data. And then how do you include new or contemporary data source that come in from social media, RFID? Now we have thread, Twitter's, sensory, web, GPS, textual data. You have IoT, Internet of Things. Internet of Things have their sensors, they have their actuators. And then maybe you have telemedicine, and then you have some devices that you capture the data from ECG, EEG, electroencephalogram, electrocardiogram, something. Yeah, so you need to integrate this data as quickly as possible so that you can analyze them. So this is what you get, big data analytics, because you want to analyze this data. So at this level, is this just BD, big data? You're moving to big data analytics, and then you need to work on a schema on demand data storage paradigm, because the data, the variety of data type, we have many kind of data, because one of the B is variety of data type involved. You need to have a schema, on demand for the data storage paradigm, because data come in and then it could be in a different format, a different type, a different variety, different so you need to have a schema on demand. So that this is velocity, where data are coming very fast at your doorstep, and then this traditional analytics could not perform it. So we have this is variety of data. We have so this volume of data. So how do we process? How do we do that big data analytics? Okay. Now, okay. Critical success factors for big data analysis. This is the critical success factors for big data analysis. You need to have a clear business need. Okay. Why? Your business needs must be aligned to your organizational strategy and your organizational vision. Why do you need to have access to big data? Okay, because when you deal with big data, you will need many more extensive or deep technologies like natural language processing. We covered, I think, in our topic, text analytics, we cover natural language processing. You may need in natural language processing, may need a technology like machine learning. You need to have machine translation. You will need many more technologies because you need to cater for data that coming in from social media, that coming in from sensory, like or location-based data, sensory data from your IoT and so on. So you need to have a clear business need because usually big data analytics are expensive. So you need to know what is the vision and what is the strategy that you would need to that you would like to apply big data. There is a need, because from the need, then only you will get a sponsorship. You need a strong, committed sponsorship, meaning that within sponsorship doesn't mean people from outside. Maybe people from your organization, your CEO or your COO or your CTO who have such strong drive. He will champion big data analytics in your organization. Why? Because it will consume a lot of money, a lot of time, a lot of effort. He need to build a team. He need to find what are the resources that you need to combine to, and then what technology that they want to use. Today we have Hadoop, with Hadoop, and then coming up for stream analytics, they have what you call it, Apache Sparkle. Apache Spark, Sparkle. Sparkle is for, or can also Sparkle. Sparkle is for ontology based. This is Sparkle. Sparkle is pronounced as SPARQL. Sparkle is pronounced as Sparkle. Apache Spark or Hadoop. Hadoop is free, but we need to Hadoop. The system is free. The application is free because Apache Spark. So that's Apache Spark or Sparkle, but the manpower is not free. The experts in the area are expensive. So natural language processing and so on. So you need to align all these needs, the needs with your IT strategy. Therefore you need to have a sponsor. You need to have somebody to be committed, and then your organization should have a fact-based decision-making culture. What does it mean by fact-based decision culture? Some organization depends on intuition. Oh, intuition. Oh, I have 10 years of experience. I have 20 years of experience. Well, this will never work. Okay, I have from my years of experience, I can see this so and so. So, but fact-based decision-making culture is we decide based on things that we can calculate very objectively by doing analysis, by figures. Yeah, so we make decision on this. Our culture is for this decision making is based on facts. We don't base on intuition or hunches. Yeah, so you need to have that, because after if you're spending a lot in big data analytics, and then finally you just based on some people's hunches or intuition, so what you have spent so far is actually is wasted. And then you need to have a strong data infrastructure. Why? Because when you deal with big data, you are dealing with large amount of data, and then you need to have OLTP, online transaction processing. Online transaction processing meaning that the data will be coming at real time, so you need to be able to process it real time. You need to have your server need to have can have multiple processing capability, or you can have multi-core, or instead of multi-core you can have break them up into multiple servers. So, and then each server you can break down, reduce, we call it, we break them into certain process so they can. So you need to have the data infrastructure in terms of the processing, in terms of the storing database, and then in terms of analysis of this database. So you need to have a strong data infrastructure. And then if you are to combine your big data with the data warehouse or a data lake, you will need a lot much larger infrastructure. And then you will need to have right analytic tools. If you combine with data warehouse, for example, you will need to have the ETL, export, extract, transform, and load. Yeah, extract, transform, and load that we have covered, and so on. So, right analytical tools, what are the tools that you want to use, and then you need to have the right people with the right skill. Some of the systems are free, but you need to have the right people with the right skill, and then they are expensive. This is the critical success factor for big data analytics. Unless you have all these, might as well you just use a cloud-based system that being offered by Amazon or something, or by Google, instead of you having on your premise at your organization. Okay, so far any questions so far? Jaime quite quiet today.
I'm listening, Prof.
Okay. Okay, Azani, okay? Able to follow?
Yes, yes, Prof.
Okay, yeah. So you should be able to distinguish big data and big data analytics. So we have data, the normal structured data that we have learned so far throughout this class. And then we have big data. And then from big data are still data, but the characteristic of data is different. The features, and then we have big data analytics, which is where you process this, the data, the big data. Okay, so the critical success for big data, these are these. Okay, you need a clear business need strong committed sponsorship. Sponsorship doesn't mean you have a sponsor from outside. It is within your organization, somebody, or in your board of director. There must be somebody who are willing to drive and they get the fund allocation to drive the big data analytics, and then you can align business. But first and foremost, you need to have a clear business need. There is necessity to have this big data analytics. And then you can align between the business and IT strategy. You have a fact-based decision-making, a strong data infrastructure, the right analytics tools, and then you have personnel with advanced analytical skills. So enablers of big data analytics, what are the enablers that you require so that you will have this and big data, you can implement this big data analytics in your organization? You need to have in-memory analytics. In-memory analytics meaning that you need to have a strong server, a big server or CPU that could process data set in RAM, random access memory, rather than calling it from the storage, yeah, read-only memory, also from the storage, from the temporary or secondary storage, like your hard drive or something. So it will load everything into your RAM and process it at the RAM level. When it's not calling forward and backward from your secondary storage, doesn't call your data. So you need to have a strong capability to process the complete data set. If you have a 1 gigabyte, 1 terabyte of data, so you can process the whole terabyte of data in your RAM, random access memory, meaning that it is in your CPU. And then you can place analytic procedure close to where data is stored. So where you look into in-database analytics. So the whole analysis is done at the database processor, at where the database is being stored. Or you can also use many machines, we call it grid computing, or multiple processor, massive parallel processing, MPP, massive parallel processing. So we have, for example, we have in universities, in Malaysian university, we have grid computing. What do they call it? Forgot the name, but they don't really use it because there is a grid of servers in universities, and then they will be able to process data when the requirement comes. Yeah, grid computing. And then you need to have appliances like hardware, software, storage in a single unit. Yeah. So this is what you need. Challenges of this big data analytics include you need to have capability to handle, to capture, store, and process huge volume of data in timely manner within the specific time. You need to integrate data, ability to combine data quickly at a reasonable cost. And then you need to be able to process data quickly when it is captured. It is stream analytics, or we call it OLTP, online transaction processing, OLTP. Yeah, online transaction processing or stream analytics. We'll discuss the stream analytics later. It's a topic, stream analytics. And then you need to have data governance, security, privacy in your organization. Who can have access to this data, and then who should have accountability and of this data and responsible of the data. Yeah, responsibility and accountability are two different things. Yeah, so who is responsible to maintain this data, and then who have or accountable in using this data. Yes, Aimee, any questions, Aimee?
Yes, Prof. You read my mind. Prof, I wanted to ask you, does Putra Business School actually uses big data analysis,
No.
analytics?
No, we don't use. We don't have the we don't have the necessity. We don't have the need to do big data analytics, and then we don't do big data analytics.
But Prof, you require students. You require to compete between other business schools, like Penang University or maybe local other universities, and so on. They have business school. So would it be better to have a big data analytics to customize, to analyze your students or your possible customers?
Oh yes, it will be interesting, but we are not that big. Our students are about less than 1,000, and then our capacity is that we even though even though we continuously market our product, we are not that big to cater for a large number of students. And then maybe with ODL we can. We just launched our ODL, or open and distance learning courses, because previously we are physical. We are very physical, very much physical, face-to-face class. So we don't have the capacity to cater for too huge number of students. So maybe with ODL there will be a necessity for us to grow big, and then only we will look into big data. But big data is not so much of in the sense of Putra Business School. It is much more for marketing, understanding the market, and so on. Yeah, so gathering information from the market, not really disseminating information. There are many purposes, many benefits that you can get from big data analytics. But for Putra Business School, as a business school, I think our benefit would be just confined to getting information, or maybe we can use it for our research, but not so much. And then comparing the benefit versus the cost for big data analytics, that is another thing that we should look at it, because cost of big data analytics is not small. Yeah.
Thank you, Prof.
Okay. And then skill availability, the other thing. The only people which is data, what do you call it, skilled to data analysis in PBS is only me. So the rest are, I am the only technical person. Compute from IT. The other lecturers are HR, accounting, management, and so. So skill availability, we also don't have the skill availability to run big data analytics. And then the solution cost, the return on investment. If you, like I mentioned to you, if we spend so much in big data analytics, but will we gain the return to commensurate the amount that we spend on this data? But I'm not sure with your organization. Amy or Jefferson or Nadira, do you think you will require big data analytics?
No, not for my company.
Over Jaime?
The same, Prof. Our customers are, you can count them in hundreds probably. Maybe our customers probably they might need in order to do the final products probably. To
Yeah,
compete with the others maybe.
yeah. Okay, okay, now the business problems that that can be addressed by big data analytics. Yeah, so we can look into process efficiency, where you look into the whole processes, you get information, and then you can compare, and then you can look into cost reduction. Brand management rely on the sentiments that people have in your product marketing. Yeah? So you can use big data analytics. Big data analytics is about anything about analytics is about decision making. Yeah, remember, we have descriptive, we have this predictive, and we have prescriptive analytics. Same thing. So with big data analytics, your descriptive analytics will be better. You can see the position of your organization in the industry, and your industry, how does it supply to the whole the other vertical or horizontal market. You can see your position. So from there, you can see the process efficiency. You can expect the market at the raw material and so on. You can analyze the whole thing instead of just confining in the normal supply chain management system, normal structured data. You only see what's closest to you. But with big data analytics, you can see beyond. Yeah, so you can do predictive analytics from there, and then you can have cost reduction. And then also when you do brand management, you can estimate the needs of the other market, position yourself by using big data analytics, because you have information, and then from this information, descriptive, you can do predictive analytics, and then you can prescribe what is the best way to position your brand. Yeah, what is the best way to position your brand? You make decision, and then you can also do revenue maximization, because once you understand the market, you can predict the future. You can see the best way how, meaning that when you process, for example, when you do Monte Carlo simulation, for example, you have running a very large of data and so on. So you are more closer, not to say accurate, more closer to accurate. So we can do revenue maximization by cross-selling or by upselling your product. You can enhance customer experience by using their sentiment, looking at their sentiment, and monitoring their sentiment, and then you improve the distribution, improve the deliverables, improve the services delivered to the customer. You will enhance the customer experience, and then you will be able to churn. Especially for large organization, you can see churning rates. Where do they go? Yeah, is there any other markets coming up? And then customer recruiting. And then when you talk about technology, when you relate to technology, I think this is one also covered. It's not covered in your topic here, but it's covered in my S. We have two types of innovation. We have what we call it sustaining innovation, and then we have disruptive innovation. So you can have churning customers. Customers could be churned to other organization, yeah. But your competitors, your possible the competitors that you could see easily will be the sustaining that apply sustaining innovation, that enhance the quality of products, they have innovation to improve their products, yeah. So it can be sustaining innovation, but you might not foresee these customers that move into disruptive innovation, the companies that are not delivering the same product with you, but delivering other substitute products that could sometimes take over your place, even if you're at the you're holding a larger percentage of the market share. So with big data analytics, you can see that you can identify the churning rate. So you can use them. You can also use big data also for customer recruitment, to convert potential customers. You can see potential customers or prospects, and then you can recruit them. You can create awareness, where to position your advertisement at a most effective manner. Yeah. So at the end, you will be able to improve your customer service. And then you can also, by identifying sustaining and disruptive innovation, you can also look into identifying new products that you can produce, and then what are the new market opportunities that you can embark on. Yeah, so what you need here is actually you need information for decision making. So where do we get this information for decision making? It's not just confined to the data that we have. We're getting data from all the sources that we can have access to over the web, or from satellite, or so we can combine everything, then you can have a better access to information, more access to data, then get better information. For information, you can improve your decision making. So it's all about making decision. Okay, and then you can also use big data to handle risk. You can identify and quantify risk. You can mitigate risk. And then you can look into regulatory compliance and to enhance security capabilities. You look into certain malware or certain hazards, moral hazards that can appear unforeseeable, maybe scammers and so on. You can improve your security, or fraud, new fraud strategies. You can monitor, you can detect the trends for fraud strategies.
Sorry, Prof.
Yes.
The data then this is business data analytics. What about, let's say, forensics or of data for immigrations, or data for, that's another type of data analytics, or is pretty much the same, big data analytics, or that's another category, let's say forensics?
It is the same. When you talk about big data, you will cover everything, every data that under the sun. So, but the process is, how do you, for example, immigration data and then medical data. So this data, that is why we say variety. We have variety of data. This data is meant for different purposes. But how do you process this data, combine them, and then integrate them to become information for your decision? Yeah, so data can come from any sources, all sources. Yeah. So forensic, or yes, so include. Okay, and then the big data technologies that we have today, up to the book, we have MapReduce, Hadoop, Hive, Big, HBase, Loom, Uzi, Ambari, and so on. So I'll not go through detail of all the topics, but we'll just go a few of them, like MapReduce and a few Hadoop and so on. Yeah, so there are other most of these big Hadoop is actually a foundation. You can see Hadoop foundation under Apache. I think I'll stop share for a while. I'll show you Hadoop website. And then we have Apache. Okay, I'll share the screen. Okay, this is where, for those keen on exploring Hadoop, okay, this is Apache Software Foundation. Apache Software Foundation is open source community that develop the HTTP server that we use. Yeah, a lot of projects use HTTP server, and then they have Solar projects. This is the project list by Apache. One of the Hadoop is here because HBase, Hadoop, Helix, Hive. So this is Hadoop or Apache Spark. Yeah, Apache Spark is here. Spark. Comparing Spark and Hadoop. So say let's go to Hadoop first. Okay, this is Hadoop, Apache Hadoop. Apache Hadoop, we have modules to process. They have Yarn, Ambari, Cassandra. So it is meant to break up the content of the big data and then to process them using HBase, which is a structured data storage, or we have Ozone, Mahout, and so on. Yeah, so it can, or including Spark as well. So it can handle no SQL, not only SQL data, not so we don't cover no SQL in our class here, but it's covered in MIS. So okay, and then HBase data storage for large database, Hive for data warehouse infrastructure, and then Mahout for scalable machine learning and so on. So these are tools that can be used freely, open source, and then basically, but Hadoop is basically for batch processing. For Spark, Apache Spark is the one that you can use for data analytics, but on streaming, or we can batch or streaming data analytics. Yeah, data that coming in streaming. Yeah, so these are the tools. So these tools are free. You can just download it here. You can just download it, but you need to know how to use them. Okay, that is the Hadoop. And then, okay, this is the technologies that you meant for big data. So all are in, you can just search Hadoop or search Apache or search Apache Spark. You can have access to this data, Flume, Uzi, Ambari, MapReduce, all are there. Yeah, Mahout, so on. So those are technology with big data. The information is available at their site. But basically, big data, for example, MapReduce, you can break up, distribute the processing of very large multi-structured data to large cluster. So you can have high performance with simple computers. You can break them up. Development popularized by Google. So it does index the web, do graph analysis and text analysis, and then you also do machine learning. Yeah. So this is MapReduce. So how this is basically how MapReduce does is break up, and then so it can process and then combine back so you can raw data, break it up into a certain map, and then combine them and summarize them. Yeah, so this is Hadoop, and then it can access to structured, unstructured data and semi-structured data, break up data into parts. Yeah. And then technical component of Hadoop include, just now I showed you HDFS, yeah, a lot of tools. And then, so Hadoop consists of multiple products, like I showed to you just the site just now. There are many products, Amari, HBase, MapReduce. So they will need to combine. It is a whole ecosystem. It is not just a single product. Say people say just use Hadoop. It should not just Hadoop is an ecosystem. Yeah, so we combine the other. So I showed you again Hadoop. Yeah, so you need to combine. This is Spark to handle this what do you call it? Streaming data, or you have all this combined. Yeah, so you need to combine all this, and then they also have their API, system API. Yeah, to use it is a whole. It is a complete ecosystem to handle big data. And one thing good, it is free. Actually, it is open source. So it is for HDFS is a file system. It is not a database management system. And then Hive resemble the where is it? Hive resemble the SQL, but it is not the standard SQL. And then Hadoop and MapReduce are related, but not the same. MapReduce provide control to analytics, but it does not. It's not the analytics. Yeah. So we have to combine the whole ecosystem. But we are not going, this is not a technical topic, so we will not be going into the detail of each Hadoop components. Yeah? But basically, you know that in Hadoop, you can use Hadoop for big data analytics, but you need to, it is a whole ecosystem. Everything is there. Even Spark is there. So it falls under, they belong to an Apache foundation called Apache Foundation. Apache Foundation is an open source community. So it is open source. So, and then whether we can use big data combined with data warehouse, we can use data, because data warehouse are very much structured data. It is a relational database management system instead of, for example, Hadoop mostly go into NoSQL, like Mongo, HBase is NoSQL. So we can combine Hadoop, but it will not replace the data warehousing. It can be integrated. So Hadoop can be a repository and refinery. So it can act as an active archive. And then you can put the data warehouse to integrate data for provide business value and then provide interactive business intelligence tools. So you can have combination of Hadoop and data warehouse. So data warehouse, you can have online analytical processing. Hadoop, you can have SQL compliance. And then you have Hadoop for raw unstructured data can be pre-processed by Hadoop. And then online archive can be processed by Hadoop. And then cleansed data can be handled by both data warehouse and Hadoop. And then they also, both data warehouse and Hadoop can handle more than 100 to 1,000 of concurrent users. And then unknown relationship, which could not be handled by data warehouse, could be handled by Hadoop. So you can combine both Hadoop and data, and then data warehouse, parallel complex process logic can be handled by data warehouse and also Hadoop. But for those CPU intense analysis that processing is very intensive, you need to use data warehouse. And then for governance, you can include, you can use in Hadoop. More flexible programming language you can put in Hadoop because data warehouse basically use SQL, structured query language. For Hadoop, it is very flexible. So because it's not based on relational database. For Hadoop, you can have unrestricted, ungoverned sandbox exploration. Yeah, you can test in Hadoop. And then analysis of provisional data you can use in data warehouse. And then for extensive security and regulatory compliance, you can use both data warehouse and also Hadoop. So you can coexist Hadoop and data warehouse to store multi-structured data. We have structured data, you put into data warehouse, unstructured data and semi-structured data, you can put in combination of Hadoop and data warehouse. But you can use data warehouse, Hadoop to filter, transform, consolidated the multi-structured data and put it up to for the data warehouse. And then Hadoop also can analyze large because with MapReduce, you can break the data into large multi-structured data and then pass it on and then publish analytical results at Hadoop level. And then you can use relational database. Yeah? You could use the warehouse. In the data warehouse, you have the relational database. So you can provide MapReduce capability for the investigative computing platform. So you can have front-end query tools to access another query tools to access and analyze this data and to combine Hadoop and data warehouse. So this is a basic diagram. If you coexist Hadoop and data warehouse, Hadoop, both we have developer environment because Hadoop is very flexible. You can have a developer environment. Business intelligence tools is very structured, handle structured data coming from integrated data warehouse. The integrated data warehouse can be in the form that we have learned previously. It can be in many architecture, various format of this this data warehouse and also data mart, yeah, operational data, database, data store, and so on. So we can have raw data streams coming from sensor data, blogs, email, web data, documents, PDF, image, videos, pass into the Hadoop, and that Hadoop will process them and pass to the data warehouse. And then in the meantime, you can also have your operational system, CRM, customer relationship management system, supply chain management system, enterprise resource planning system, other legacy system, third-party system. You can extract, transform, and load into the data warehouse. And then we can use them for your business intelligence tools, which we can move on to your business analytics tools, yeah, upper here. And then, okay, the level.
So, Prof, in Hadoop itself, there are components for text and web mining as well.
Hadoop, yes, it can, but it can handle, but the target is handling non-unstructured data.
Understood.
Yes, so so you can have developer environment here, yeah, to deal with graphics, images, natural language processing, and so on. And then you can pass on back and then pass to the data warehouse, because data warehouse handles structured data. But there are pros and cons between data warehouse and Hadoop. Yeah, so the list that I've showed to you just now, pros and cons between Hadoop and data warehouse. When you are able to coexist, so you have the best of both system, both component. Yeah, for big data and for big data, if you are not doing big data, you don't have to have this complicated thing. If you are doing big data analytics, yeah. Okay, these are software vendors for big data, Cloudera, MapReduce, and so on. Yeah, so this is the IBM InfoSphere for big data, and big data platform for Teradata Esther. Yeah, and then this urban and rural commodity networks, big data. So how to succeed in big data is to simplify the big data, to coexist with the to coexist, and then to visualize, to empower, integrate, govern, and evangelize. Yeah, so you need to keep track of all the new database vendors. So you need to simplify the data. You need to coexist with the several database platform. So you need to visualize the data, yeah, changing the way you look at the data. So you need to empower the organization you need to make decisions. They use big data to make decisions, and then you need to integrate big data with your current systems, and then you need to govern this big data, and then you need to have sponsors, evangelists. You need to have evangelize. You need to have sponsors that motivate this big data. Yeah, and that we have data in motion because when we say big data, big data have velocity. So big data means that data coming in very fast, and real-time analytics. We have data in motion analytics. So how do you process it very fast? We have a term called stream analytics versus perpetual analytics. Yeah, stream analytics is where it is not possible to store the data or lose its value. For example, when you look in at the stock market change, stock market, the commodity market, the stock market, yeah. So it change every second, every minute. It change every second. So you cannot wait until end of the day and then you process this data. So data need to be processed immediately. So your analytics in terms of pricing, in terms of PE ratio, in terms of the whatever changes in the environment, you not need to be done on the stream. So we cannot wait. So it is for critical event processing and also real time. So these are meant for stream analytics compared to perpetual analytics. Perpetual analytics you do at the end of the day or time by time. So that is perpetual. Yeah. So in this is stream analytics, example streaming analytics in industry, in the energy industry. It's a case. So stream analytics is used in e-commerce, in telecommunication, law enforcement, financial services, health services, government, power industry. Yeah. So you require to use stream analytics. Yeah. So it stream analytics is the difference between stream analytics and purposeful analytics. Purposeful analytics, you are able to compare your data with the previous data. You have time to compare the data with the previous data. But stream analytics, you are not able to compare with the previous data. So once it comes in, you need to make decision. So it be done at real time. Yeah, so it is not possible to store the data because not worth to store the data, because the next minute the data doesn't have value anymore. Okay, the stream data, so you can predict usage and so on. Okay, that is so far the topic 9. So we'll cover topic 10 after this. Any questions so far? Any question? Otherwise, can we take a break? So before we move on to the next topic.
Yes. Sorry, Prof.
Yes.
I wanted to ask you about the quiz number 3. You remember last week we discussed that, Prof?
Yes. Okay, I'll give you the answer. I will upload your LMS. Yeah.
Prof, you already did it. So please B and C. Appreciate it, Prof.
Okay, thank you.
Thank you. Thank you.
Okay. And then any other question? Thanks for reminding me. I almost forgotten actually. Jamie, thanks for reminding me.
No problem.
Okay, any question? We will take a break of can we do 10 minutes? And then 9:15 we start. 10 minutes. Yeah, 9:15 we start. Yeah. Take a break of 10 minutes. Okay. Okay, can we continue on the next topic, which is the last topic on the future trends of business analytics. Future trends, privacy and managerial consideration, business analytics. We begin with the topic of Internet of Things. Internet of Things come with the development of the what we call IP version 6. With IP version 4, the number of internet protocol addresses, IP addresses was confined to 255.255.255, maximum. You can only go to 255.255.255.255. So the number of IP addresses that could be catered in any system or any network is only confined to these permutations. But when this is IP version 4. Then in IP version 6, yeah, IP version 5 as well, IP version 5. And then with IP version 6, we have this is 32 bits process, 32 bits, 32 bits IP address. Then with IP version 6, it is IP version 6. Instead of this is the numbers is actually binary from 0 and 1. This is binary. Okay, with IP version 6, we have alphanumerical. Yeah, we can be alphabetical and numerical IP address. Alphanumeric and that at 128 bits. So with this, we have we have large number of IP addresses that we could give everything. We have IP addresses. Now we can give IP addresses to everything. So there is connectivity of the internet is getting larger. It's very huge. So we can connect, instead of connecting computers, we could connect things. So we have Internet of Things. We connect everything. So it will be an explosive growth. It will be connecting all the physical world, every devices, every equipment, everything to the internet. So it's not just connecting human. We can connect machine to machine. We can connect our lighting to our air condition system, to our computer system, to our refrigerator, things at home, or things at our offices, or things at our plant, factories, and so on. So everything could be connected directly using their own specific IP address. Currently, we apply local IP address for certain officers or certain. We create local IP addresses. With IP, with the IP version 6, we do not require the local IP. We can just use this normal the provided IP by our telco. So everything could be connected. So with this connection, we can also enable sensors and sensing devices. So everything will be connected. So we have self-driving cars can be connected with sensors. Will be connected to the internet. We can have fitness trackers with their own IP addresses, connects to all the other devices. We have smart bin, we have smart refrigerator, and so on. So this is what we call Internet of Things. So with this Internet of Things, they are becoming the source for data. So they provide data. So how do they provide data? So besides computing and communication devices, where there will be 38 billion things connected to the internet. So we have, besides the IP addresses, besides the internet and IP addresses, the hardware are getting bigger and getting smaller and affordable and more powerful. For IoT, we have Raspberry Pi and Arduino, for example. Arduino, and then Raspberry Pi. PI. Raspberry Pi, ini ada Pi. 22 divided by 7. Raspberry Pi, and availability of BI tools, more capable and cheaper. So we have more emergence of newer and innovative use case. So, and then we have Internet of System, Web of Things. So everything will be connected to the internet. Yes, so it is Internet of Things. So these are source of data. So IT related technology components are divided into 4 major blocks, which is the hardware. We have physical devices, sensors, and actuators. Yeah, actuators delivers this from the sensors. We pass to the actuators pass to the physical devices. Yeah? Maybe your refrigerator and so on. And then connectivity. So you collect and send all the sensory data to cloud. So cloud become the collector for all this data. And then we have software, like for example, Hadoop, that we can integrate and process data for patterns. Yeah, Hadoop, or we saw Spark, we covered just now, Hadoop, Spark, HBase, and so on. And then we can create many applications, yeah, based on the context, yeah, but specific alerts or actionable insight that you want to develop applications for. So this is the application. We have IoT devices connect to our home of plants, factories, offices, and we have applications. So we have data and we have gateway. So provide requests and analysis. We have internet network, and then we provide data storage, cloud storage in the cloud. It's actually, the cloud is actually not on the cloud. It is on premises, but the term cloud is actually is a server farm that organizes data and process data as a service. Yeah, process data, software as a service. We have infrastructure as a service, database as a service, and so on. And then we have RFID sensors, RFID. Yeah, besides IoT, just now we talked about IoT, Internet of Things, the explosion of Internet of Things. From this explosion of Internet of Things, we have a lot of data. The next is RFID, radio frequency identification. Radio RFID is just identification based on radio wave. So it could be used to provide codes, provide IDs in form of radio frequency waves. So it can be in numerical, alphanumerical ID of 70, 80, over 100 digits. So difficult to be duplicated. Yeah. So it could be, or if there is even a smaller 1-bit processor at the stores, some store outlet, retail outlet, we have a 1-bit processor, 0 and 1 to be used. That is also RFID. There is how does RFID work? We have a tag. Tag is the sticker or a tag placed in a device, at the device, car, or in your chip, in your price tag, and so on. So it's a, and then we have an interrogator. Interrogator is, it detects the objects. And then there are two types of RFID, passive and active RFID. Passive RFID doesn't have power source, no battery, so it's small, inexpensive. So it waits for the interrogator to interrogate them. Or active RFID, it is a larger, more expensive, as power source. It has a battery. So active RFID active tag will emit their signal, whereas passive tag will wait for the interrogator to detect them. So retailer usually use passive tags, but other maybe use active tags. So for example, I know that Daimler-Benz uses the tag. I'm not sure whether passive. There are systems that use active tags. Yeah, they emit their RFID signal, their identification signals. So RFID can, plus the sensor can be used for perishable goods. So you have sensors to detect the RFID, you monitor the date, expiry, and so on. And then data will be a representation of a given application domain. It will be in this binary code or decimal code or UCC code. Yeah. So this is just an example with 96 bits of data. I've seen that there are some data we have more than 96 over 100 bits. Yeah. So combining this RFID will provide also data. Besides the IoT, RFID also provide data. So now we have access to large amount of data in the future. Yeah, combine this, we have also fog computing. Fog computing is data being produced in IoT, is very huge. So it need to be pre-processed at another node. We call it fog computing. Fog computing is a processing of a node, is a node to process data coming from the IoT. So you have devices in IoT, it linked to a fog first before going to the cloud. Yeah. So the fog node can include router or switches, but it will be processing the data coming from the IoT devices. So imagine you have sensors or RFID collects this data, pass on this and IoT, and then IoT pass on to the fog nodes, from the fog nodes, then only to the cloud. Yeah. So the fog nodes will receive data from this IoT device, and then it will pass on to the cloud. The cloud will receive and aggregate data from these fog nodes. Yeah, so we have IoT, something like this. IoT. We have another IoT. And then it will link to a fork node. Pass data to a fork. And then from this fork, it will pre-process this data and pass on to the cloud. So this is the future where we will have large amount of data coming from sensors. This is coming from sensors.
Prof, is edge computing similar to fog node?
Yes, similar. Edge computing. There is a different edge computing is fog node is the node. Yeah, fog computing is the node. There is a difference between, there is a slight difference between edge computing and fog node. I don't recall it because I've given that in one of my class, but I do recall the difference between edge computing and fog node. Okay. The difference between edge computing and fog node. Edge computing is closer to the user. Yeah, edge computing is closer to the user, whereas fog nodes is closer to the cloud.
Okay, and I think I can visualize. Yeah.
Yeah. So from sensor, so edge computing, they have device, they have systems that collect closer to the computer. For example, like in motor car, what do you call it? Driverless car. We have smart cars today. Smart cars, not just driverless car, but smart cars. These smart cars we can have. They are connected. They are connected cars. These are connected cars. It is connected to another car. It connects to the road. They have sensors at the road, and also connects to all the edutainment or entertainment or edutainment system. So we can have music, information, or what do you call it, podcast, yeah, in the car. At the same time, we are communicating with the car front, at the front of us or at the back of us. So, and then I think something like that. So it combines everything. We have a edge computing. Edge computing is closer to the user. Okay, that is the concept of edge computing. And then move up, sensors, and then we have IoT, and then we have fog computing. Fog computing gathers the data to move to the fog, to the cloud. Gathers data. Fog, yeah. Edge computing is more of processing. Yeah. So fog computing gathers the data, collects the data, aggregates the data, so it can pass on to the cloud. So what cloud receive is actually a pre-processed data. So so these are the IoT consideration would be IoT platform, Amazon Web Service, IoT, Azure, Predict IoT, and so on. And then there are IT startup ecosystem. Yeah. So this is Internet of Things. Content design 3D. This is 2016, very old. Yeah. And then managerial consideration in the Internet of Things, we look into organizational alignment, interoperability challenges. How do you align your organization with the use of Internet of Things? Maybe in your robotics, in the we have today, we call it fourth industrial revolution. We have a cyber physical world where using IoT, we can link all the robotics machineries to the IoT, and then it can communicate, and then we pass on to the cloud and so on. So this fourth industrial revolution. And then how do you align with your organizational HR training, yeah, training that you provide to the and then we have change management, you have business transformation, yeah. How do you align with your organization? Yeah, this is from the management perspective. You need to align with your change management and so on, training and so on. And then how do the interoperability challenges, because maybe you require some middleware, or how does you interoperate between one system to another system. Yeah, so the challenges, and security, because people will have access through the internet. People will have access to through your internal processes and internal systems. Yeah, so we have emerging growth of IoT to for the vision of smart cities, smart grid, and everything to be smart. So cloud computing is the a style of computing that is dynamically scalable, virtualized resources. So you provide services over the web. So user does not really need any detailed knowledge. So it rely on the cloud, and the infrastructure on the cloud will support the user. So it is a utility computing. We have infrastructure as a service. We have a platform as a service. We have data as a service, or we have software as a service. Yeah. So this is cloud computing. This is the future of business analytics. We will have we will process. Example, which will be storing data for email messages, stores the software, centralized hardware, software infrastructure, and so on. Yeah, cloud computing example. And then the business model for cloud computing will be pay per use. Usually it's pay per use. When you use, you pay. If you don't use, you don't pay. Or you can subscribe them. Yeah, pay as you go. Companies that cloud, I think the most popular for cloud computing services is provided by Amazon. Yeah? Amazon Web Service. Salesforce also have web, cloud computing. Salesforce is a CRM company. Azure, I've used Azure in IBM. Yeah. And then when you look into cloud computing, you need to look into service-oriented architecture, service-oriented thinking. So it is providing service, so you are using the service of another cloud provider. So it can be reused, substitute, accessible, scalable, customizable, reliable, low cost of ownership, and economies of scale. Yes, service orientation. So building an agile data information analytics capability as a service to the customer. That is service-oriented thinking. Service-oriented thinking, where we have information, all this coming from ERP, passed on to the metadata, data mart, everything is in the cloud. So, and then you provide the services, yeah, to the other system. Everything is in the cloud. Okay, we have data as a service. You can have access to your data. Data is kept in the storage in the cloud. It provides service. And then software as a service. You use software. You don't have to install the software in your device. Software is in the cloud. You subscribe to that software. For example, like 360 Microsoft, we have Office 360. So we provide service of 360. Software as a service, platform as a service. You combine, for example, as Magento and Shopify. Magento provides some model for your e-commerce platform. Yeah, e-commerce platform as a service. Infrastructure as a service provided by Azure, provided by Amazon Web Service, and then there are so many as a service emerging. Yes. So different types of cloud offerings. We can have virtualization, server, storage. Yeah? This is our infrastructure as a service. Platform as a service. You can have runtime, middleware, operating system, virtualization, server, storage, networking, platform as a service. And software as a service, where you have all from the application data, runtime, middleware, operating system, virtualization, servers, storage, and networking. All are managed by the cloud vendor. Yeah. And then virtualization of cloud computing. We have essential technologies for cloud computing. One is a virtualization. So the users feels like they are using the whole system, whereas they are sharing the services in the same server with other customers. So we have storage virtualization, server virtualization, network virtualization. So you feel like you control the whole server, the whole storage. It is virtualized. But actually at the back end, there are one server which is being shared by 10 customers. So that is virtualization. We create a virtual system like operating system. So we have a server run Microsoft server. For example, we have another server runs Linux, CentOS, or Red Hat Linux, or Fedora. And then this Microsoft server is shared with 10 customer. And then we have Fedora, another server, Apache open source software using Apache, shared by another 10 customer. But each customer feels like they are using their own server. But actually at the back end, it's only one server. Okay, and then we have cloud deployment models. We have private cloud where organizations like government, they develop their own cloud, but it is meant for their own organization, private cloud, or public cloud, Azure or Amazon provide cloud services, pay per use. You use when you pay when you use. Or you have hybrid cloud meaning it combines partially hybrid, partially private and partially public cloud. So which cloud model is is suitable for you depends on your security level, because some content is you're not worried if it is accessible by public, and then you can use it public cloud. But there are more contents or database which is very secure, very sensitive, that you do not want to share to others. Maybe you put into a private cloud, or you can have a combination. So you have a hybrid cloud. Yeah. So it depends on your requirement. So these are analytics as a service offering. So it's analytics as a service, AAAS, yeah, analytics as a service. Teradata, Watson Analytics, SAS, yeah, Tableau, Snowflakes. So this is just an example, yeah, example given here. And then we also have location-based analytics. Analytics are specifically more for geospatial, according to visual map, postal code, latitude, longitude. For example, we have Waze, we have Google Map. Yeah, so it is location-based on analytics. When you travel, you can do analysis and expect you to arrive to a certain location at certain time, calculating the number of other customers, other travelers, and then the traffic jam and the congestion and so on. So these are location-based analytics. Yeah, so it can be organization-oriented or customer-oriented. Organization-oriented, we have geospatial static approach, where examine geographic site location, or location-based dynamic approach. We provide real-time live location feed for real-time marketing and promotion, or geospatial static approach, where we have GPS navigation and data analysis. Yeah, so like Waze and so on. Or location-based dynamic approach, where we have demand analysis, predictive parking, and so on. So these are. So geographical information system is used to capture, store, analyze, manage data located based on a location, linked to a location. It will combine with integrated sensor technology, global positioning system. Yeah, and then it provides intelligence, location intelligence. We have map so that you can drill down. For example, like Google Map can go down up to 4 or 3 meters. Yeah, drill down. So location for retailers, we can use this to, but a lot of telcos actually doesn't really offer this, because the customer doesn't want to have to receive information. But we can still find, when, for example, when you use Google Map, you can still find if you want to search for information. So, for example, where is the nearest food restaurant or your hotel, they will be able to provide you location, yeah, location proximity. And then we can analyze customer needs and complaints and so on. So, and then for geographical information system application, you can provide meant for agricultural applications, crime analysis, disease spread prediction, for example, they use in COVID-19 situation. Yeah. So this is just an example. You can watch this YouTube video later on. And then we have real-time location and intelligence. So, for example, Waze. Yeah, so you can see, monitor the GPS, Wi-Fi, RFID tower triangulation, because your GPS that you use in your mobile phone is actually cellular mobile. It's based on the tower, the cell tower triangulation. And then from the cell tower triangulation, it will go up to the GPS satellite. And then GPS satellite will provide the location, and then it will triangulate the location between the towers to estimate your location. Yes, that is real-time location intelligence. Other analytics application for consumer include iOS. So these are the consumer. So I'm not going to go detail into this. And then in terms of legal issues to consider when you use data for is whether this analytics could be what is the value of expert opinion in court when expertise is encoded in the computer? Who is liable for giving wrong advice when you do analytics, and you provide information? Who is liable? And then what happens if a manager enters into an incorrect judgment based on analytic application? Who owns the knowledge in the knowledge base? You hold a knowledge base. Okay, from your data, we have information. On top of information, we have knowledge base. Knowledge base is the codification of knowledge from experts. Yeah, so who owns knowledge? Whether it's the experts or the system, can management force experts to contribute their expertise? For example, you hire a lawyer, a doctor, a physician, and then you want to develop a telemedicine system. Whether you can get a knowledge engineer to interview the physician and collect the data, say how do you determine how people obtain or become diabetic, and then what is the diagnosis for diabetics, how do you treat the diabetics, how for certain, and then you capture them into a system. So who owns this knowledge? One is who owns this knowledge. Is it the company, or still with the experts? Or and then the next question, can management force experts to contribute their expertise to codify their knowledge into these systems? So these are the issues. The other issues is privacy. In terms of collecting information about individuals. In Malaysia, we have Personal Data Protection Act. I think in your home country, there will be similar laws to control personal data protection, and then mobile user privacy, where they are able, for example, today, the Google Map, those using Google Map or Waze, they can analyze, they can profile you from where you have been, that you're traveling information. Yeah. So ethics in decision making, and the issues is on electronic surveillance, on software piracy, on invasion of individuals' privacy, use of proprietary database, use of knowledge and expertise, accessibility for workers with disabilities, whether they have the same analytics capability, accuracy of data, information, knowledge for decision making, and then maybe used in court, in cases, protection of rights of users, accessibility of information, personal use of corporate computing resources for users, analytics for your own purpose or your own agenda. So these are analytics revolution, cultural revolution, will be from the organizational unit, people analytics, activities, performance and satisfaction. We will have organizational design and management using analytics, and the industry impact of the automation, and then impact of analytics for future job, and then you will have the organizational impact of analytics. So you can be in the future, we have a specific business intelligence department. We can have specific data science department. I think some organization already have, because the book is in 2016. By today, 2023, we have some analytics department. We have people analytics and HR analytics. Yeah. The impacts of analytics on management would be lack of expertise and experience. You will require faster decision making, can be augmented with analytics. Yeah, so we can have faster decision making. You can have less reliance on experts and analysts because you can make decisions based on analytics. Prescriptive analysis can help you to make decisions. Power is being distributed among managers because managers can be able to use analytics to assist them in making decisions. So support for complex decision making can be faster to develop and better quality. Information needed for high-level decision making is expedited or can be self-generated with the ability of analytics. And then you can have automation of routine decisions or phases of decision making, yeah, which can eliminate some managers because routine tasks could now be computerized or automated. Yeah, same like what have happened in tellers. We don't have tellers anymore with the advent of automatic teller machines. So maybe with the analytics, certain decisions which are routine can be decided or totally rely on structured data, structured decision making. It can be automated. Yeah, so impacts on analytics in organization, there can be in industrial recognition, industrial restructuring. So when they recognize artificial intelligence, analytics, and cognitive computing, so it can restructure the industry, or we can have automation impacts on jobs. We talk about IR 4.0, Industrial Revolution 4.0, where we have cyber physical world, where we connect. The idea of cyber physical world is to connect machine with computers. Yeah, the idea, if you read the paper by Schwab, is about connecting machine with computers so that computer can control the machine and the machine could be automated, do their tasks both without human. So computer doesn't need human, machine doesn't need human. We have IoT, we have Web 3.0. Web 3.0, we have pervasive computing, where computer can deal with machine, machine can do the job. We have robotics, automation, and so on. So we do not need human to reduce number of manpower, reduce number of costs, and then machines can work 24/7 without resting. Until maybe a certain time, we can have redundancy. You can have another robot to take over for a certain period, and then continue back another robot and so on. And then computers, we have redundancies of servers and so on. But it can run very effective, more efficient, especially for routine things. Yeah. So we can have unintended effects of analytics. Yeah. So we can we can replace humans' job. Okay, that is the end of this topic. We have 10 minutes for Q&A. Any question? Stop share. Yes, Jefferson, Jaime. The notes you can refer for this topic. Topic 10 is actually very narrative. You can look into chapter 8 in the book. Yeah, chapter 8 in the book. The topic 9 is actually in chapter 7 in the book. Okay. Any question so far? Azani, Nia, Christopher?
Hi, Prof.
Yes.
I just want to ask, because earlier on you mentioned next week got presentation, right? I just want to check because I didn't have in my schedule yet. So
Yes. Next week, the other class. When is the next class?
next class is 20. Wait, hold on.
The following week.
I think 26.
Yeah,
26,
26.
right? Yes.
Not next week, right?
Yes, not next week. The other
Okay.
week, your last class, your presentation is on the last class, but you're supposed to submit your group assignment next week. So that I have 1 week to go through your paper. You'll be presenting on your dashboard. There should be 2 dashboard. One dashboard for the clinic manager, the other dashboard for the COO. For the clinic manager, it will be about the staffing, about bedding, and so on. But for the COO, it will be about the operations, the general operations of the company, and it will include the balance scorecard. Balance scorecard, there should be 4 components of balance scorecard. Only one is the financial matter. The other 3 will be on the internal operations. Will be the internal operations. Will be on the growth and learning, and then will be on the customer. Maybe customer, there are complaints of the customer. You can include in if you do have sentiment analysis and so on. But up to you. Okay, any questions? So I think everybody's ready for your. I think you have another week to prepare your assignment. Then you can put it up in your LMS. If you have problem, just communicate with me. Maybe you can. I'm not very familiar with the new LMS system. You can put up the LMS, or you can email it to me later. Just let's see how, if you have face any problem.
Prof,
Yes.
sorry, just to double confirm, so 19 July will be the submission of the report and the
Yes.
26th will be the presentation, right?
Yes.
All right. Okay. Thank you, Prof.
Sorry, Prof. For the individual assignment, so group assignment, individual assignment. So group assignment next week on the 19th. So for individual assignment, when will it be?
In the individual assignment is after your last class, meaning that the day of your last class is 26. Your last class is 26, right? So you submit on 26.
The individual assignment, 26.
26. And then also together with your presentation slide, you'll be presenting on the 26th. After end your presentation, you submit your presentation slide, and then do it together with individual assignment and your case studies. There are 3 case studies. Only the case studies number 2, which is in Excel format. The other in Word or PDF format.
Prof,
Yes.
one more thing. So that would mean that the date of the individual assignment submission on LMS is to be changed, right?
Yes.
Okay.
Okay. Because I allow. Actually, just put it there, but I will allow it to. If you have any problem, just communicate with me.
So the date will be same as the quiz, right?
Yes.
Okay. All right. Thanks, Prof.
Okay. And then, okay, any other thing, Amy?
Yes, sorry, Prof. So the 20 for the presentation, which is on the 26th of May, the presentation. So there will be presentation about the assignment, the individual assignment, and it's being presented. Am I right?
No, just the group.
The group assignment that he has provided on the 19th.
But it is an individual presentation, individually marked, because everybody in your group must present, so it will be individually marked.
Correct. Correct. That's what I meant.
Yeah.
Okay.
Okay, and then for individual assignment, of course, it is individual, and then your examination, I will communicate with the admin. Should be 72 hours, 24 times 3 days, yeah, not 36 hours.
So they will be on the 17th of August.
17th of August. You should receive it in 17th August, and then you will submit it on the 20th, right? By 5 p.m. Okay, any other question before we adjourn? I think we can adjourn.
Yes, Prof. You will be sending for
Yes,
the
I will
kids.
say, okay, I will be sending okay, I'll be sending it in the WhatsApp. I think I shouldn't be sending the question, the answer.
Do you want me to send you a reminder, Prof? It's
Okay,
okay.
can.
I will do that. I will do
Okay,
that, Prof.
then.
Thank you.
Okay.
Thank you, Prof.
Okay. Any other question before we adjourn? Yeah, Ma. Yes.
When I ask for the quiz submission, we submit all three quiz under the MS quiz part.
Yes. All the
Uh,
3 quiz. Only one, but one is in Excel format. Then the quiz number 2, which is in Excel format.
Okay, noted, Prof. That's all.
Okay. Okay. If there is nothing, we can adjourn for tonight. Thank you very much and see you again
Okay, no problem.
on your presentation. Okay.
Okay, Prof.
Prof.
Thank you,
Thanks.
Prof.
Good night.
Bye.
Thank you,
Prof.
Prof.
Thanks.
Good night, guys.
Thank you, Prof.
Thanks.
Thank you.
Thank you, Prof.